In this video, we cover the essential questions and answers every Pega developer should know. From foundational concepts to practical applications, these interview questions are tailored for beginners and those looking to strengthen their Pega knowledge. This Part 1 video covers basic Pega interview questions that are commonly asked in real-time interviews, based on previous experiences. In the next video Part 2, we will cover more advanced real-time asked Pega interview questions for experienced candidates, including scenario-based questions with examples. Stay tuned for the next video. What is Pega and why is it used in business process management? Pega is a business process management (BPM) and customer relationship management (CRM) tool that provides a platform for developing and automating enterprise applications. Built on Java, it helps organizations streamline and automate complex business processes through case management, workflow automation, decision management, and robotic automation. Pega allows for creating applications with minimal coding due to its model-driven, low-code development environment. This accelerates delivery, reduces costs, and provides scalability and agility for evolving business need. What are some new features of Pega 24.2? Pega 24.2 introduces enhancements to the Pega Infinity platform, emphasizing AI-driven decisioning, low-code development, and better cloud integration. Some notable features include generative AI. Rapidly build apps with Pega Gen AI Blueprint, analyze data with Pega Gen AI Analyze, and get context-specific guidance with Pega Gen AI Coach. Enhanced decisioning. Improved decision models and algorithms for better decision-making. Expanded LLM choice. Choose from more language models to power your AI app. Data integrations. Seamlessly integrate with Google BigQuery and Snowflake. Improved UX. A more intuitive and user-friendly interface. Explain the concept of case types and stages in Pega. Case types in Pega represent a business transaction or process, such as onboarding a new employee or processing a claim. A case type is designed to achieve a particular outcome, broken down into multiple stages and steps. Stages are the major phases in a case lifecycle, representing milestones that the case must go through from start to completion. Within each stage, there are steps or assignments that guide users through tasks or decisions needed to progress to the next stage. Case types and stages help organize complex workflows into manageable parts, making process management simpler and clearer. What is a rule in Pega and why is it essential? In Pega, a rule is the fundamental building block of applications, defining the behavior and functionality of processes, user interfaces, integrations, and decision logic. Rules can be reused and customized without duplicating logic, ensuring consistency across applications. Types of rules include decision rules, UI rules, validation rules, and integration rules. Rules enable Pega's flexibility, allowing changes to application logic without hard coding, which accelerates development, improves maintainability, and supports rapid adaptation to new requirements. How do you create your own case studies in Pega? To create a case study in Pega, follow these steps. Define the case type. Start by setting up the case type, which represents the specific process or transaction you want to manage. Design stages and steps. Structure the case lifecycle by adding stages, phases, and defining the steps within each stage to represent actions or decisions. Configure rules. Use rules for decision-making, data collection, routing, and integrations as needed. Set up user interfaces. Build forms and screens using Pega's UI tools to capture inputs and guide users through case processing. Testing and deployment. Test the case type in a development or test environment and make adjustments as needed before deploying it to production. What are PxPages in Pega? In which scenarios can we use them, and how do they work? In Pega, PxPages is a property type that holds references to external data pages, allowing Pega applications to access data outside the current context. PxPages enables efficient data sharing across multiple cases or processes without needing to duplicate the data. They're used in scenarios where you need to fetch or reference information from other case types, integrations, or data objects dynamically. Use cases. Common scenarios for PxPages include cases needing to reference customer data from an external CRM, pulling in data from external databases, or using data from another case type within the same application. How they work. PxPages are defined in a data page or data transform where the reference data source is specified. When a case accesses PxPages, Pega retrieves the reference data at runtime, so the data remains current and consistent. What is the difference between authentication and authorization in Pega? Authentication. This process verifies the identity of a user trying to access the Pega application. Pega supports various authentication mechanisms like single sign-on SSO, OAuth, LDAP, and basic authentication. Authentication ensures that users logging into the Pega platform are legitimate and allowed access to the system. Authorization. This process controls access to specific functionalities and data within the Pega application based on the user's role, permissions, and access group. Authorization determines what an authenticated user can see and do within the application, such as access to certain cases, reports, or administrative tools. What is the background process involved when an operator logs into the Pega application? When an operator logs into Pega, several background processes occur. Authentication. The user's credentials are validated through the chosen authentication method, e.g. LDAP, SSO. Session initialization. Upon successful authentication, a session is created, and the user's details, like access group, roles, privileges, and locales, are loaded. Clipboard setup. The operator's clipboard is populated with data relevant to their session, including personal details, work objects, and application rules. Access group and application context. Pega determines the access group and application context, which influence the user's permissions, access to cases, and availability of features. Dashboard home screen loading. The user's default dashboard or home screen is displayed based on their access group settings, and Pega begins loading any personalized content or relevant assignment. Can you explain the class structure and layer structure in Pega? Class structure. Pega organizes objects and rules into classes in a hierarchical structure. Major class categories include: Work. Contains case types which represent business processes. Integration. Manages external system integrations, including connectors and services. Data. Houses data types and objects used within the application. Layer structure. Pega's layer structure promotes modular, reusable designs. It typically consists of: Organization layer. Contains elements shared across all applications within the organization. Division layer. Houses components specific to a division, like regional rules or specific policies. Framework layer. Contains generic, reusable rules and assets that can be customized in the application layer. Implementation layer. Holds application-specific configurations, rules, and cases tailored for the business's unique needs. How do you create a work object in Pega? All three ways. A work object in Pega is a record of a case in progress. There are three primary methods to create a work object. Through a flow. The most common method involves initiating a case flow, where users complete forms or steps, and the flow creates the work object automatically. Using an activity. You can write a custom activity with the addWorkObject method to programmatically create a work object, commonly used in automation or batch processing scenarios. Through case type instantiation. By directly instantiating a case type from a data page, activity, or API call, developers can create a work object outside a traditional flow, which is useful for custom integrations or external triggers. These methods allow flexibility in case creation, from interactive user-initiated cases to automated, programmatic approaches for specific business need. Can you explain the rule-based architecture of Pega? Pega uses a rule-based architecture to develop, manage, and execute business processes. Key components of this architecture include: Rules. Pega's reusable components that define application behavior, such as UI, sections, layouts, business logic, decision tables, when rules, data handling, data pages, and integrations. Rule resolution. Pega's engine evaluates and selects the most appropriate rule at runtime based on parameters like the user's access, rule availability, version, and application context. Rule resolution enables dynamic rule selection, which is crucial for handling multiple application versions or customizations. Inheritance and reusability. The rule-based architecture allows inheritance, where rules from parent classes are reused and overridden in child classes. This modular approach enables reuse and reduces redundant code. What are the types of validation in programming languages like Pega? In Pega, validation ensures that data entered by users or processed in workflows is correct and consistent. Validation types in Pega include: Property validation. Ensures values entered for properties, fields, meet certain conditions like mandatory fields, value ranges, or formats, e.g. date, phone number. Rule-based validation. Uses edit validate rules and validation rules to specify complex or conditional validations. Declarative validation. Automatically validates data based on declarative rules, such as constraints that enforce relationships between fields. Flow action validation. applied at specific points in a workflow or process flow to check data when users submit forms or complete assignments. How do you handle validation rules in Pega? In Pega, validation rules can be managed in multiple ways. Edit validate rules, used to define specific criteria that property values must meet. These rules are commonly used for format validations, like email or phone number format. Validation rules define conditions that need to be met before the system saves data to the database. You can apply validation rules at the case, data, or process level to ensure completeness and accuracy. Constraints rules. Declarative rules that automatically enforce specific conditions on properties without user intervention. They can be used to ensure consistent relationships between properties. Flow action validation. Configured within the flow action to validate inputs when users submit forms. This can include mandatory field checks or conditional validation based on user input. What authentication is used in Pega while an operator logs in? Pega supports several authentication mechanisms for operators. Basic authentication uses username and password credentials stored in Pega's internal database. Single sign-on (SSO) integrates with identity providers, IDPs, like SAML, OAuth, LDAP, or OpenID Connect to authenticate users via SSO, streamlining the login experience. Multi-factor authentication, MFA adds an additional verification step, such as SMS codes or authenticator apps, to enhance security. Custom authentication services allows custom logic to validate users, suitable for specialized or organization-specific authentication requirements. How does Pega manage rule versioning? Pega handles rule versioning through rule set versions. Each rule set, a collection of rules, contains multiple versions that track changes to rules over time. Key aspects of rule versioning in Pega include rule set and rule set versions. Each rule set consists of multiple versions, e.g. January 1st 01, January 1st 02, allowing you to manage changes systematically. New versions are created when updates are made, preserving previous versions. Checkout and check-in mechanism. Developers can check out a rule to make changes, ensuring no conflicts arise. After modifications, the rule is checked in, creating a new version in the rule set. Branching. Branch rule sets allow development in isolated spaces, enabling teams to work on enhancements or fixes without impacting the main application version until merged. How can you create custom sections and layouts in Pega? Creating custom sections and layouts in Pega allows you to design user interfaces that meet specific business needs. Open the section rule. Start by creating or editing a section rule in the application's design studio. Sections are the building blocks of UI in Pega. Add layouts. Choose from various layout types like dynamic layout, repeating layout, grid layout, or column layout. Each layout organizes content differently and serves specific design need. Add fields and controls. Drag and drop fields, buttons, text inputs, drop-downs, and other UI controls onto the layout. Customize with styling. Use the skin rule to apply custom styles to layouts, making the UI consistent with branding and design guidelines. Use conditions and visibility. Set conditions on sections or layouts to control when they appear based on case status or user roles, making the UI dynamic. What are data pages and how are they used in Pega? Data pages in Pega are centralized structures used to source, cache, and manage data from external or internal sources for use within applications. Data pages, also known as declare pages, are categorized based on their scope. Thread level, scope to a single thread and reloaded when necessary. Requester level, shared within a user session, requester, across all threads. Node level, available globally for all users and sessions on a server, making them ideal for frequently accessed data, e.g. lookup tables. Data pages can be sourced from databases, REST services, SOAP services, or other data pages. Pega refreshes and reloads data pages according to their configuration, refresh conditions, which helps avoid redundant data retrieval and improves application performance. What are decision tables and decision trees in Pega? Decision tables and decision trees are rule types in Pega used for business decision-making. Decision tables. These define conditions and corresponding results in a tabular format, similar to an if-else ladder in spreadsheet form. Each row contains conditions and actions. When conditions in a row are met, the specified action or outcome is returned. Decision tables are useful for handling simple to moderately complex business logic, where each row represents a rule. Decision trees. These provide a hierarchical structure to evaluate conditions sequentially. They work like a flowchart, where each node represents a condition, and branches lead to subsequent conditions or actions. Decision trees are beneficial when business logic involves multiple, nested conditions. Both tools simplify decision logic and make it easier to visualize and maintain decision rules. How do you manage database performance in Pega? Pega offers several techniques to optimize database performance. Database indexing. Proper indexing on frequently queried columns can enhance query performance. Declarative caching. Data pages with caching enable quick access to frequently used data, reducing the load on the database. Efficient query writing. Use optimized SQL queries in report definitions and obj browse methods to fetch only required data, minimizing unnecessary data processing. Avoiding large clipboard objects. Reducing unnecessary data on the clipboard. Pega's in-memory storage prevents performance issues related to memory consumption. Purge and archive policies. Regularly archiving or purging old data prevents the database from becoming too large, which can slow down operations. Database monitoring tools in Pega, like PDC, Pega Diagnostic Cloud, also provide insights into database performance, helping to detect and resolve issues proactively. What is a security policy in Pega? What are the different security policies used? A security policy in Pega defines rules and practices to secure applications and protect sensitive data. Some common security policies in Pega include password policies. These define the complexity, expiration, and reuse criteria for user passwords, ensuring strong authentication practices. Account lockout policy. Limits the number of incorrect login attempts before locking an account to prevent brute force attack. Session timeout policy. Specifies how long a user can remain inactive before Pega automatically logs them out, protecting against unauthorized access. Multi-factor authentication. MFA adds an additional layer of security by requiring users to verify their identity with a second factor. IP whitelisting. Restricts access to the application only from specific IP ranges for enhanced control. Data encryption policies. Encrypts data at rest and in transit, ensuring data privacy and security. These security policies safeguard the application, data, and user access, enhancing overall security. What is Pega PRPC, and what are its core functionalities? Pega PRPC, Pega Rules Process Commander, is a comprehensive software platform developed by Pega Systems. It is primarily used for business process management, BPM, customer relationship management, CRM, and case management solutions. PRPC enables organizations to automate, optimize, and streamline complex business processes, ensuring efficient workflows and enhanced productivity. Core functionalities include process and case management, rule-based decision-making, and UI design with customizable forms and layout. Pega supports integration with external systems, offers robust security, and provides tools for reporting and analytics. Its scalable architecture handles large transaction volumes, making it ideal for enterprise environment. Pega PRPC's rule-based architecture allows easy updates, ensuring agility and efficiency in business operations. What are the common debugging tools in PRPC, such as Tracer and Clipboard? Pega provides powerful debugging tools to troubleshoot and optimize applications. Tracer is a key debugging tool in PRPC that records and displays the sequence of rule executions, events, and steps taken during processing. It allows developers to monitor rule execution, view parameter values, and identify issues with business logic, making it essential for troubleshooting complex processes. Clipboard is Pega's in-memory storage where data related to cases and processing is held temporarily. The Clipboard tool allows developers to inspect and modify this data directly, which helps in debugging and testing applications by showing real-time values of properties and pages. How does PRPC integrate with external data sources? Pega PRPC can integrate with external data sources using various methods. Connectors. Pega offers several connectors such as SOAP, REST, JMS, and SQL connectors, which allow PRPC to communicate and exchange data with external systems or APIs. Data pages. Data pages act as an interface to fetch data from external sources and cache it within Pega. They can source data from connectors, databases, or other services. Database integration. PRPC can directly query external databases through JDBC connections to retrieve or update data. Queue processors and services. For asynchronous processing, Pega uses message queues or queue processors to handle integration with external services and applications. How are UI components handled in PRPC? Explain sections, harnesses, and dynamic layout. Pega PRPC uses a modular structure for creating user interfaces, which includes sections, harnesses, and dynamic layouts. Sections are reusable UI components that contain fields, buttons, and other controls. They represent individual parts of the user interface and can be reused across multiple screens. Harnesses define the overall structure of a page, specifying where and how sections are displayed within the interface. Common harnesses include New, Perform, and Confirm, which organize screens for creating, working on and confirming cases, respectively. Dynamic layouts. Dynamic layouts provide responsive design capabilities, allowing sections to automatically adjust based on the screen size and orientation. They support grid, stacked, and inline formats, making it easy to design fluid, mobile-friendly interfaces. What is the role of a certified Pega system architect, and what are the core skills required? A certified Pega system architect, CPSA, is responsible for designing, building, and implementing Pega applications to address business process need. They focus on translating business requirements into technical solutions using the Pega platform. Core skills required include Pega platform knowledge, understanding Pega's architecture, rule-based design, and development tools, process flow and case management, expertise in defining case types, stages, and process flows to model business processes, data modeling, creating and managing data structures and integrating them within the application, user interface, UI design, building user-friendly interfaces using Pega's UI component, decision-making rules, designing decision tables, decision trees, and declarative expressions, security and performance tuning, knowledge of best practices to secure applications and optimize performance. How do you approach building a Pega application from scratch as a CPSA? To build a Pega application from scratch, follow these steps. Gather business requirements. Meet with stakeholders to understand the application's objectives and requirement. Define case types and stages. Model the business process by defining case types, stages, and steps which structure the workflow. Set up data models and integrations. Define data types, classes, and properties. Establish data pages and integrate with external systems if necessary. Configure user interface, UI design forms, sections, and layouts to provide a seamless user experience. Implement business logic. Create rules, decision tables, and other logic components to define the app's behavior. Test and debug. Conduct unit testing, system testing, and user acceptance testing to ensure quality and functionality. Optimize and deploy. Fine-tune performance, apply security measures, and deploy the application. Explain the process of creating data models and classes in Pega. To create data models and classes in Pega. Define data types. Start by defining data types that represent business entities, e.g., customer, order. Create classes. Organize the data types into a class structure within Pega's class hierarchy. Typically, classes are defined in layers: work, data, and integration. Add properties. Properties define the data fields within each class, e.g., customer name, order amount. Establish relationships. Use properties like page and page list to define relationships between data objects. Data pages. Set up data pages to source data dynamically, either from a database or external APIs.